All right, today we're going to start chapter 7, which is going to deal with rational equations and expressions. And today is the first section of that, with 7.1 being the inverse variation. Okay, with two learning targets. Learning target number 1 is that you're going to be able to classify direct and inverse variation equations. And then learning target 2, that you're going to be able to write inverse variation equations based on different data sets we give you, whether it's an equation or a data set or some variation of that. Okay, the very first thing you're going to need to know is what is an inverse variation. Okay, inverse variation is when two variables, let's say x and y, they'll show an inverse variation when they are related as follows. Y is equal to an a value divided by x, where a can be any real value except for 0. Okay, and then a is the constant of variation, and y is said to vary inversely with it. Okay, so before we start classifying inverse and variations, direct variations, or neither, let's actually just go and look at some general equations that will go with each. Okay, so let's start with inverse variation. We know that the starting point for inverse variation is y is equal to some value a divided by x. Okay, and so I can take this and I can manipulate this equation such by, like, for example, I could multiply by x. Okay, and so if I multiply by x on each side, what's going to happen is I'm going to get x, y is equal to a. And so this gives us an alternate form of what an inverse variation equation is going to look like. So now we have two equations. X times y is equal to a, or y is equal to a divided by x. And this is quite helpful because I can understand what inverse variation is just by looking at the equation rather than actually having to do any other work, like such as graphing or plotting or making a table of inputs and outputs. Okay, a direct variation, okay, is going to be in this form: y is equal to k times x. Okay, and so in this particular one, it's very, very similar to the inverse variation. It's just k is our constant value, but k cannot be equal to 0 as well. So when we look at this here, our equations are the same, except for instead of we're multiplying by x here we're dividing by x. So that's really the core difference between the two. Okay, this one also can be manipulated to give us two general forms. I can divide by x here on each side, and now I get an alternate form. Y divided by x is equal to some k value, or that original part that we started with. So anytime you see an equation in either of these forms where I'm dividing my variables and getting a value, or when I have y is equal to k times x, I know that's a direct variation. And then an inverse variation would be x times y is equal to a, or y is equal to some a value divided by x. And if you have an equation and it doesn't fit into any of these categories, that means it's neither direct nor inverse. Not all equations are a direct variation or an inverse variation. So let's talk about an inverse variation. An inverse variation is as a graph increases, or as a variable increases, the other variable is going to decrease. That's what an inverse variation is going to be. Whereas a direct variation, as like one goes up, the other one's going to go up, or as one goes up, the other goes down. So we can actually look at an example of an inverse variation. Okay, so this would be an example of an inverse variation. Over here I have my equation, y is equal to 2 divided by x. So anytime I have like an x value of, this looks to be like 1 here, my y value is 2. When my x value is 2, my y value is 1. And see, just kind of as the x's are increasing, this y value is decreasing. Okay, whereas if I had a similar one that would be a direct variation, it just forms a straight line, so we can actually get rid of this now. So as my x values are increasing, as are my y values. When x is 1, y is 2. When x is 2, y is 4. And so these are the relationships that the graphs are going to have between each other. So let's go back to our original task and actually identify and classify some equations. Okay, it's pretty straightforward. Basically what you're going to do is you are going to look at the equation and see whether it fits nice and neat into one of these general equations, and if it doesn't, it's neither. If it does, it's whatever one it fits into. So 1, xy is equal to 5. So we just got to find the general form it fits into. Okay, it fits right here. Okay, so if you look, it's just the x and y variables are being multiplied by each other. So I got to find the general form down here that just has my x and y variables multiplying by each other, and that seems to be right here. Okay, so I know x times y is equal to a, so I know that number 1 is going to be an inverse variation. And for the sake of our notes, I'm going to go ahead and put in a reason why I know this to be true. And it's in the form xy is equal to a. Pretty straightforward. Okay, let's look at number 2. Y is equal to x minus 4. So as you look below in your general equations here, not one of these has an addition or a subtraction symbol at all. So really, we're seeing this subtraction of 4 here. That's really clarifying to me that it's probably none of those. So this is going to be neither. And we can just put it doesn't fit a general form. Okay, and then number 3. Number 3 says y divided by 2 is equal to x. Now, if we look at this one here, we don't really have a form below that refers to like y value divided by a number, like k or a. So it doesn't seem that it fits any of these, and so your intuition might say, hey, this is going to be, neither, but really this equation can be manipulated. So let's see that happen. So I'm going to do this over here. So I have y divided by 2 is equal to x, and I can manipulate this equation easily. So let's just try to get the y by itself, because that's going to be pretty easy. I can just multiply by 2. And so now I have y is equal to 2 times x. Okay, so now this equation here fits very nice and neat into the general equation for direct variation. It's in the form y is equal to k times x, where k would be equal to the number 2. So this is going to be a direct variation. And in the form y equals k times x is my reason why. Okay, so what is a great thing for you to do right now is pause the video, okay, and then try A, B, and C independently on your own, okay, and then I am going to do these 3 here in a moment, and then you can go ahead and check your work, okay. So pause the video right now and go ahead and do A, B, and C. All right, so now I'm assuming that you've already paused the video. You've already done these 3. So let's go ahead and check our work. Okay, 6x is equal to y. And so this one looks actually a lot like this here, but instead of 2, it's 6. But the x's and the number are on the left side of the equal sign. Well, that doesn't matter. Equal signs can be flipped around. So this is going to be another example of a direct variation. Okay, B, x times y is equal to negative 0.25. Okay, and so this is pretty clearly similar to number 1, where we say it's like an inverse variation because it's said x times y is set equal to some number, okay? The only thing that might throw you off is like this number is a negative and a decimal. Doesn't matter, okay? It can be set equal to any number except for 0, any real number except for 0. So this here is an inverse variation. Okay, then letter C finally. So letter C is y plus x is equal to 10. Okay, so similar to number 2, we have some subtraction here. And this one, the only difference is there's addition. So when you look through your general forms below, there's nothing that fits. It doesn't fit into any of the general forms. So this is going to be neither situation. Okay. If you need more assistance or over something like this, please just seek somebody out and we will get you the help you need. Okay. The importance of understanding the general equation forms of all of these is that these general forms can help us classify data as well, whether data is an inverse variation or a direct variation. Okay, and we're going to do that right now. Okay, so we're going to tell whether x and y show a direct variation, an inverse variation, or neither. Okay, and then we're going to write the equation if it is a direct variation or inverse variation. Okay, so basically what you're going to do is you're going to check, does that data fit either of the general forms? Okay, so your general forms are x times y equals a and y divided by x is equal to k. Okay, we need to remember that this top is checking for inverse variation while this bottom is checking for direct variation. Okay, so what we're going to do is we're actually just going to take x times y. So let's do for this first order pair, x times y. 2 times negative 12 is negative 24. Okay, here, y divided by x. Negative 12 divided by 2 is negative 6. Okay, so let's do the same thing for the next ordered pair. 4 times negative 6 is negative 24. And then 6 divided by 4 is negative 3/2. Okay, so this is a very important part because we don't want to have to do more work than we really want to. Like, why do more work when it's just unnecessary? So when I'm looking at the direct variation, I already know that it's out of the question, not a direct variation, because if it was a direct variation, y divided by x would be equal to the exact same number every single time. And we already have a mismatch of numbers, so I know, and hopefully you now know, that this is already not a direct variation. So let's just keep moving because we don't know whether this is an inverse variation. We need to check all of the ordered pairs to see if it's equal to that same value. So x times y, 6 times negative 4 is negative 24. Okay, and again, this is unnecessary, so I'm not going to do it. And then we're going to do x times y again, 8 times negative 3, which is negative 24 again. So this is negative 24. Okay, so when I look at this, my inverse variation, x times y is equal to a constant number. So this is great. This is going to tell me that it is an inverse variation. Okay, and now I just have to write the equation for it. Okay, and so pretty much straightforward starting point. We know that x times y is equal to what number every time. So you need to think about what number is x times y always equal to? Well, it's always equal to negative 24. So that can be our starting point. X times y is equal to negative 24. Now, if you're taking a test and you're doing this problem, I would take this 100% as perfect work because it's mathematically correct. Although, more than likely, you're going to see the y variable isolated. So you're going to see y is equal to negative 24 divided by x. So I would prefer to see this answer here, although I would not count it against you if you left it as x times y equals negative 24. Okay, number 5 is going to be the exact same thing. The only difference is this just done. If you haven't figured it out, we're probably just not going to get inverse variation here. We're probably going to get direct or neither. Okay, Let's just see what it looks like, though. We'll go through doing proper work, and we will check all. Okay, so x times y is 2 here. And then y divided by x, 2 divided by 1 is also 2. Okay, and so x times y is equal to 8. Okay, and then 4 divided by 2 is 2. Okay, so just like the previous problem with the direct variation, I already know that I don't have to continue to check x times y, because I already have a mismatch of numbers. So the fact it just can't be an inverse variation, because x times y has to be equal to the same number every time, and this one is not. Okay, and so then this one here, 8 divided by 3, well, that would just be 8/3, because that doesn't divide. So I have a mismatch in numbers here. I have 2, 2, and 8/3. These are not the same number. Okay, so what does this tell me? That this is neither a direct nor inverse variation. And therefore, there's no equation for us to really have to write. Okay, so just like previously on the first page, now is a great time to pause that video, take a shot on your own on D&E, see what you get, and then cross-reference it with what I'm about to do right now. So I'm assuming that you've already paused this video and you've already tried these problems. So I am going to go ahead and do these. Okay, and I'm going to go relatively quick. X times y here is 60. X times y here is 60. X times y here is 60. And x times y here is 60. If you want to see that it isn't a direct variation, you're going to go y divided by x. 60 divided by 1 is 60. And then 30 divided by 2, which is 15. There's our mismatch in number. Can't be direct variation. Therefore, this is an inverse variation. And the equation is going to be xy is equal to 60, with your ideal answer being y is equal to 60 divided by x. Okay, let's do the next one. Here, x times y is negative 80. And then the next one here is negative 45. Okay, 15 times negative 3. So here's our mismatch. We're not going to have that. Okay, and then here, y divided by x is going to be a negative 5. 20 divided by negative 4 is negative 5. And then 15 divided by negative 3 is also going to be negative 5. 10 divided by negative 2 is negative 5. And then 5 divided by 1 is negative 5. Okay, so we have this constant value of negative 5. Okay, and that's the y divided by x. So y divided by x is going to tell me that this is going to be a direct variation, specifically with the equation being y divided by x is equal to negative 5. Okay, and then just like the previous problem, we do have a more ideal answer, and that ideal answer for me would be with the y value by itself. Not required, but just generally that's how you're going to see these. So let's go ahead and do that. Y is equal to negative 5x, right? Because we would multiply by x on each side, canceling this out and getting negative 5x here. Okay, seek me out if you need more help with these particular types of problems. Otherwise, I'm going to continue to move on. Okay, so now we're actually going to write some inverse variation equations, okay? And we're going to do that via just giving minimal amounts of information. We have to write the equation that represents it. So we know that the variables x and y vary inversely, and then we want to use the given values to write an equation relating x and y. So this statement here is incredibly helpful, because this statement helps me understand that I have an inverse variation. That statement tells me that I have an inverse variation. Therefore, I'm going to use the general forms of an inverse variation. Okay, so you can start with either one, xy is equal to a, or y is equal to a divided by x. Either will get you to the proper result. But let's just start with x times y is equal to a. So now we have an equation here, and it's got three unknowns. It's got x, it's got y, and then it also has a. And we need to think about how can I find that a value so I can just write the equation with the general variables x and y plugged in there. So how can we do that? So you should be thinking to yourself right now, how can we do this? Like, what kind of information do I have that can relate those together? Well, the information is actually just written right above. We know that y, when y is 4, x is 3. This is like an ordered pair of an equation. When x is 3, y is 4, and when y is 4, x is 3. So we can actually take that information and plug it in. We know that 3 times 4 is equal to a. And then this left side we can simplify to 3 times 4 is 12. So we know 12 is equal to a. Okay, so I think I've seen in the past, it's pretty common for students just to stop at this point, but you haven't really done what it's asking. You've done all the hard work, the work that shows me that you have some understanding, but you haven't gotten to the actual answer, because it says we want to use the given values to write an equation relating x and y. So we got to write our equation, right? We know that x times y is equal to a, but we know what a is now. We know a is 12. Okay, so I would accept this exactly like the previous problems. I would accept this, but we do kind of have a little bit more of an ideal answer, and that being y is equal to 12 over x. Okay, 7 is going to be the same thing. All right, so we know that x times y is equal to some value a. We know that x is 6 in this situation. X is 6. And that y is -1. Okay, so that's just me plugging in x for 6 and y for -1, and that's all equal to my a value. And so when I multiply these together, I'm going to get -6 is equal to a. Okay, so then we can write our new equation, which is going to be xy is equal to -6. But the ideal answer I would prefer to see personally would be -6 over x. And again, if you're doing these problems on a test or however you're doing it, I would take either of those as acceptable. Okay, if you haven't figured it out yet, I'm going to ask that you pause the video. Pause the video, try F and G on your own, okay, and then cross-reference what you did with my work as practice. Okay, so pause the video and give it a shot. Okay, I am under the assumption that you have already paused this video and you're about to check your work. So we know that xy is equal to some value a. Specifically, x is -5 and y is 4. Okay, so that means we know -20 is equal to a, and I got -20 from -5 times 4. 4 groups of -5 is -20. So I would take this equation, yx or xy is equal to -20, or y is equal to -20 divided by x. It's kind of what I would prefer to see, but I can be flexible. Okay, g is basically the same thing. It just has a fraction, so I know most of you all are already very intimidated by that, although you shouldn't be, because the problems can be done the exact same and it just requires some multiplication. There's our general form. We know that this is an inverse variation. Again, because of the statement saying that the variables x and y vary inversely. Okay, so we know that they vary inversely. Therefore, we can plug in our values. We know x is a half and y is 8. I made a little mistake here. Y is actually 16. I was doing a little work in my head. I'm jumping the gun a little bit. No biggie. Okay, so that's a 16, just so everybody knows. Clearly a 16, looks just like 1. It's not messy at all. We just have to multiply these together. 1/2 times 16 is simply asking the question, what is half of 16? So this is 8. That's why I put the 8 there, is because I kind of knew that coming ahead. All right, so let's go ahead and say that our equation is xy is equal to 8, or the equation y is equal to 8 divided by the x variable. Okay, last problem. So, number 8. Number 8 is more of a word problem. But here's the nice thing. I know that you all aren't the biggest fans of word problems, but this particular one shouldn't be too bad. It's just asking us to write an inverse variation question. And in my experience with students in the past, we haven't had a ton of problems with the examples that we've done above. And really, this just an application of that. Okay, so let's see what that looks like. Okay. Modeling with mathematics. So number 8, the time t in hours. So that's pretty important. We know that t is representing hours. That it takes a group of volunteers to build a playground varies inversely with the number n of volunteers. Okay, so now I have my variables. I know that t is going to be my time, specifically in hours, and n is going to be my number of volunteers. Okay, and then furthermore, this statement. Okay, let's read this again. The time t in hours that it takes a group of volunteers to build a playground varies inversely with the number n of volunteers. So that means that it creates an inverse variation, which makes perfect sense. So as we saw in that graph at the beginning of this lesson, that as one variable goes up, the other one goes down. So let's think about this. As the time it takes me longer to build a playground, you would expect less people working on it. As opposed to, as I get more volunteers, the less work you would expect it to take. More people, more tasks to delegate. It kind of fits nicely into this concept of what an inverse variation is. Okay, so then it adds some more information for us. For example, it takes a group of 10 volunteers 8 hours to build the playground. Okay. Make a table showing the time it would take to build a playground when the number of volunteers is 15, 20, 25, and 30. Okay, what happens to the time it takes to build the playground as the number of volunteers increases? Which we kind of already know the answer to. Okay, so let's go ahead and just build our table right now. Okay, we know that we have a table that's representing t, which is hours, and n is volunteers. And we already have a bit of information. We know that when the number of volunteers is 10, the time is exactly 8 hours. And I want to know what happens when I have 15, 20, 25, and 30 volunteers. Okay, so let's go ahead and think about this. We can write an equation just as we did in the previous problem. For example, we know that t times n is equal to some a value. So let's think about, how do I know this? I know this because of the statement that we read, the very first sentence of this whole thing. The time t in hours that it takes a group of volunteers to build a playground varies inversely with the number of n volunteers. It says it varies inversely. So I can use the general form for an inverse variation because I know they inverse fairly. Okay, so let's go ahead and plug in some information. I know this ordered pair. I know that when it's 8 hours, I'm going to have 10 volunteers. Okay, so we know that 80 is equal to my A value. Okay, so now I can write an equation. The first of which is time times the number of volunteers is equal to 80. Okay, and so now, you know, some of you may asking, because in the previous problems I had asked, like, I want the y by itself in an ideal answer. Although, you can do all the work and get here. What variable do we want by itself here? Now, it's really kind of up to you which one you choose to put by itself. But, you know, looking at what we're trying to find the time. So it makes sense to have the time variable isolated here. So let's divide by n on each side and say that time is equal to 80 divided by n. Okay, and really you could go the other way and you could have n is equal to 80 divided by the time, and that would work. But we already have the number of volunteers, so we want to just go ahead and do this work here. Okay, so let's go ahead and find the information that we can use to fill the table out. Okay, so the first one is t is equal to 80 divided by 15. Okay, so this is when n is equal to 15 for this here. Okay, and so then we could just take 80 divided by 15. Okay, and we get 5.3 repeated. Okay, so we can actually convert this into something pretty nice and neat. So let's think about what 5.3 repeated really means. Well, 5 is going to be 5 hours, but 0.3 repeated is a third. So we got to think about how many minutes is 1/3 of an hour. So a third of an hour, well, there's 60 minutes in an hour. Take that 60 minutes, you divide it by 3, that's what a third is. So 60 divided by 3 is 20. So we know that this is 5 hours and 20 min. Okay, so 5 hours, 20 minutes. Okay, do not mistake this for like 5 hours and 30 minutes or 5 hours and 3 minutes. Okay, 0.3 of an hour, a third of an hour is kind of what that represents. Okay, let's do the next one. Next one is going to be n is equal to 20. So I know that the time is equal to 80 divided by my number of volunteers, 20 in this situation. Okay, 80 divided by 20 is just 4. So we just know that this is going to be 4 hours. Okay, why don't you all pause the video right now and just take the time and try to fill out the remaining 2. Okay, so I'm going to move forward right now. I'm going to do the remaining 2. Go ahead and check your work because I'm assuming that you've already paused the video at this point and tried these. Okay, so same thing. We're going to go ahead and plug in n is 25. So that means my time is equal to 80 divided by 25. So we know t is equal to, well, 80 divided by 25. Just 3.2. Okay, so we know that it's 3 hours. We got to think about how many minutes. 0.2 is a fifth. Okay, so 0.2 is a fifth. You can see this here. If I decided to go 1/5 is 0.2. So a fifth of an hour. Okay, so we can take our 60 minutes and we can divide it by 5 to figure out how many minutes it's going to take. And in fact, it's going to be 12 minutes on the dot. So this is going to be 3 hours and 12 minutes. So we can fill that in. Okay, and last but not least, 30 minutes. Or 30 volunteers, sorry. Okay, so we know that when we take the 80 and we're going to divide it by the number of volunteers, which is 30. So we know time is equal to 80 divided by 30. Okay, which is 2.6 repeated, right? So this is 2.6 repeated. Okay, so 0.6 repeated is 2/3. So let's think. If 1/3 is 20 minutes, what's 2/3 going to be? 40 minutes. So it's going to take 2 hours and 40 minutes. All right, so that's the table. That's the meat of the problem. Let's go ahead and answer that final question. What happens to the time it takes to build the playground as the number of volunteers increases? Okay, well, we've actually already answered this question like before we even started or did any like number crunching or organization of our work. Okay, we know as the number of volunteers increases, the time will decrease. Okay, so now what's a great time is, as we've already finished 7-1, now's a perfect opportunity to go ahead and get out your 7-1 homework. If you do not have a copy of that, go onto our website, the Mac Math website, and go ahead and find the Chapter 7 section under Algebra 2, and go ahead and you can print your own copy, or if you don't have a printer, feel free to just do it on a separate sheet of paper, and I would accept that as well. Everybody have a great day.